In this video, we're going to talk about conic fillets and what they mean to your surface designs. Now, in a previous chapter, we talked about conics in dealing with 2D sketches. Now, conics are basically a plane and how that plane intersects a cone, and that's how your different conics are formed. Let's talk about conics in relation to fillets. Now, typically when you're dealing with fillets on your designs, you're adding a constant radius of curvature. So if we simply go into fillet under constant size and select an edge, let's say we add a 1/2 inch radius. We take a look at the curvature of that fillet. You can see that we have our black sections, which has 0 radius of curvature, and then this green section, which has a consistent radius of curvature. Now, what this means in your overall design is that when light hits this and when you're dealing with reflections and shadows, you're going to see a hard edge between these two differing curvatures. And that's usually a bad thing when you're dealing with product design. So let's take a look at some of the different things that conic fillets can help you with. So conics are available for constant size, variable size, and face fillet, and we'll take a look at each of these. So first, let's deal with constant size. We're going to select that same edge, and under Profile in your fillet parameters, we have the option to select conic row and conic radius. We'll deal with conic row first and deal with conic radius next. Conic row is basically going to be a ratio, and this ratio is in relation to your fillet radius. The ratio goes from 0 to 1, but you're only allowed to enter values between 0.05 and 0.95. If you enter the value of 0.5, this ratio defines basically the same fillet as your circular profile. If you alter this ratio, for instance, if we go down to 0.05, what you're actually telling it is the ratio between the relation of the surface that's connecting it and the surface that it's creating for this fillet is very small. It's limited to a very small area of this intersection. So we don't necessarily have a straight edge. We have a very gradual curve between the two, and then a sharp curve at the edge. If we change this to 0.95, the highest value we can reach, that's basically telling it that you have a much higher influence from the surrounding surface, and the straddle point or the shoulder point, the peak of your fillet, is going to have a much sharper curve. So this is basically defining the weight, if we want to take it in a context of doing something like a boundary surface, the weight of the interaction between these two. Let's take a look at what a 0.75 ratio does for us when we look at the curvature. So as you can see, as opposed to a constant radius fillet, we actually have a very nice blend of curvature between the two. But you'll notice that we still have a sharp transition, or a fairly sharp transition, between our radius of curvature of 0 and the radius curvature, what's calling 9, as soon as we get into this blue section. So this again is a much better step. It's a step in the right direction, but it's not giving us a great definition or a great interaction between these two. So let's take a look at our last option, and that is the conic radius. So again, we're going to select the same edge. We're going to go down to our profile and select conic radius. Now, conic radius allows you to define the fillet radius, and then it also allows you to define the radius of curvature at that shoulder point. So if we define this as 0.5, again, we have the same type of fillet as that circular reference. And we also have the same type of fillet as conic row when conic row value is set to 0.5. If we set this value lower, like say 0.05, then what we're telling it is the radius of curvature in this corner, in this shoulder point, is much smaller. So again, this is like the conic row in the fact that if you set conic row to 0.95, a very high value, you get much more weight, much more interaction between the surrounding surface, but you're just defining it in a different way. If we set this value higher, such as 1, then what we're saying is the radius of curvature at the shoulder point, at the peak of this, is much higher, and it's actually a larger radius of curvature than at the edge. So let's set this value smaller, set it to 0.1, and let's take a look at the curvature. So you'll notice again, we have a nice blend, but again, we don't have that nice smooth transition between the edge. But this again is a much better option than doing a standard equal radius of curvature throughout the whole fillet. So let's go back and take a look at some of the other fillet options. So as I mentioned, you can use this for constant size, as we just showed. You can use it for variable size, which allows you to define points along your edge or multiple edge selections. You simply have to change the profile to either conic radius or conic row, and at each point you'll be able to define those values. But let's take a look at a face fillet option. So typically, face fillets will allow you to get away with a little bit more change in curvature between the parts. Now, one thing you'll notice whenever you're dealing with an edge that has a drastic change in the angle between it, for instance, we have a 90-degree angle over here, but we have a much smaller angle as we get closer to the edge, your fillet actually narrows as it goes down the part because it doesn't need to be as wide to achieve the same radius of curvature. Now, we have a few options when we're dealing with this type of fillet. We have a radial type or a chord width type. When you're set to radial, you're actually defining the radius of curvature. You can set the profile to circular, you can set it to conic row, conic radius, or curvature continuous. Now, these are a lot of great options, but we also have the option to set it as chord width. Now, this will keep the width consistent along the entire fillet. Now, this is great for different types of product design where you need to keep that consistent. But you'll notice that the profile is now limited to circular or curvature consistent. If you need to use the chord width option, most of the time, curvature continuous is going to be the best way to go. So let's take a look at radial, and let's take a look at conic row and conic radius in this case. So our conic row, again, is defined as a ratio. So if we set this to a higher value, you'll notice that it's actually failing because of the limited angle at the end of our part. If we set it to a lower value, such as 0.1, it has a much better chance of actually creating this fillet. Let's set it to conic radius. So with the conic radius value set higher, such as 0.75, you can see that we're able to complete this fillet. And if we set it lower, such as 0.1, it has a much better chance of completing this as well. So where conic row was actually failing at one extreme or the other, conic radius is actually working a little bit better. So this is a great way to make a nice smooth transition between the edges of your part.